Okay, good morning. Happy Wednesday. Let's take a look at our calendar. Today is lesson 21. We're talking about solving quadratic equations with two techniques. I'll point out a couple of things going on this week. Today is a Wednesday, but officially, according to GCC's day calendar, it is a Friday. So you're going to your Friday classes today. Doesn't affect us because we meet the same time on Wednesdays and Fridays. But if your Wednesday-Friday schedule is different, today is a Friday for you during the day. Anybody have a Wednesday night class? So we're going to those tonight, Wednesday night, but the day is Friday. Also coming up this Friday, we have no class. Veterans Day, I think, is Saturday, but we honor it on Friday. So no classes on Friday, so the next time we will see each other is going to be Monday. Any questions on the calendar? Okay, so here we are at the top of page 169. In this lesson, we solve quadratic equations by using the square root property and by factoring. So here is the first equation we're going to solve. X squared equals 16. So in order to solve that equation, we need to somehow do something that will get x by itself, which means we're looking to do the opposite of squaring a number. What's the opposite of squaring something? Square rooting. So I'm going to write up here the same equation, and I'm going to actively take the square root of both sides. So that is the operation that we are performing, the thing that we are doing to both sides. Just like it's legitimate to add 3 to both sides of an equation or to divide both sides of an equation by 17, it's legitimate to take the square root of both sides of an equation. We're doing the same thing to both sides. Okay, on the left-hand side, square root of x squared, that's easy, that's just x. And the square root of 16 happens to be a nice number, that's 4. So x equals 4 is our solution. Let's just double check. If you plug 4 into the original equation for x, is the equation true? 4 squared, does it equal 16? Yes, it does. Sadly, that is not the complete set of all numbers that work. Can anybody name another x value that will make this equation true? -4. If you take the number -4 and you square it, that means -4 times -4, and we again get positive 16, but we missed it. So at the exact moment that we take the square root of both sides of an equation, we need to put in our fancy plus or minus symbol, and that will get us a complete set of answers. So it's written down here in bold and italics. When you take the square root of both sides of an equation, you must put in plus or minus. Don't have a great way to help folks remember to do that. I will tell you that there is a theorem. It's not really part of our course, but I'll share it with you here. It's called the fundamental theorem of algebra. There are lots of theorems in algebra. Like the first page of this packet is a whole big chart full of theorems in algebra. But there's only one thing called the fundamental theorem of algebra to give you a sense of the importance of this particular one. And here's what it says. When you have an equation, the number of solutions you are going to get is equal to the highest power in that equation. The highest power in that equation is 2. We're expecting 2 solutions. If you don't put that plus or minus, you get x equals 4. That's a single solution. We're missing one, okay? Whatever the highest power is in the equation, that's how many solutions you'll get. So for example, earlier this semester, or a bunch of this semester, we solved equations like that. What's the highest power on any x? 1. And how many solutions are we going to get when we solve this equation? We're going to get 1. All of the linear equations that we solved this semester, of course you're going to get 1 because that's the highest power anywhere. But if I make this a 3x to the 5th, now how many solutions is it going to have? It's going to have 5 solutions. We're not going to solve any like that, but the fundamental theorem tells you whatever the highest power is, that's how many solutions you're going to get. So x squared equation, 2 solutions all day, every day. That'd be easy to catch the omission of that plus or minus. Okay, let's take a look at another one. We're going to try this one down here. Where is it? 7x squared minus 1 equals 199 plus 3x squared. So I think, where are we going to put this? I'm going to squeeze this one over here. So here's the first technique. The first step is to isolate the x squared. Get the x squared by itself, which means move all the x squared terms to one side of the equation and everything without an x squared to the other side of an equation. So let's first move this 3x squared to the left by subtracting it from both sides. So I had 7x squared. I'm going to subtract 3x squared. I'm going to be left with 4x squared. And then that minus 1, I want to get that away from the x squared, so we're going to send that to the right by adding 1 to both sides. So we get 4x squared equals 200. It's okay. All the x squareds to one side, everything else to the other. Okay, we're now one step away from accomplishing this goal, which was isolate the x squared. I don't like that 4 near the x squared, so what do? We divide both sides by 4, so we get x squared equals 50, okay? And now that the x squared is by itself, this looks exactly like the first equation we solved today. What do we do to both sides at this moment? Take the square root. Take the square root of both sides. All right, so we'll put this in here. X squared equals 50, and we are taking the square root of both sides. And what do we have to remember to put in at that exact moment? When you take the square root of both sides? Plus or minus, that's what you put. Only at that moment. Okay, and so in this case, left-hand side, square root of x squared, that's just x, equals. Okay, so the plus or minus I'm copying. Now, the square root of 16 was the first problem we had, and that simplified nicely to just plain old 4. The square root of 50 doesn't simplify nicely to just a single rational number. But we do have, like on the last quest, you had to simplify radicals like this. And so our goal was to find the biggest perfect square that goes evenly into 50. Perfect squares are here in yellow. We're just going one at a time. Does 4 go into 50? It doesn't. Does 9 go in? It does not. Does 16 go in? Does 25 go in? Does 36 go in? What goes into 50? 25. So then we write 50 as 25 times whatever you need to still make 50. And then we got our answer here. Plus or minus square root of 25 comes outside and becomes 5. And then the square root of 2 is still in there. That's our answer. Plus or minus 5 times square root of 2. Okay, and so after you isolate the x squared, it's pretty straightforward. So you just have to remember that step right there, isolating the x squared. But I want to point out there was something special about this equation that we circled in purple that made this technique work, whereas the technique won't work on this green equation. If you try to take, so I'm taking a look at the green equation. The x squared is by itself, so it feels like I'm at this moment where I have x squared equals 50, right? And what did we do at that moment? We took the square root of both sides. So that's a totally fine thing to do up here. But the problem is I have just buried an x inside of a square root. That's not good. Like the left-hand side is good, but the right-hand side is no good anymore. And so if your equation has both an x squared and an x term, then this technique is just not going to work. And we're going to see a technique in just a minute that will work. But I want to point out the equation circled in purple was really special, even though you didn't recognize what was special about it until right now. That equation in purple has no term with just x, like the 25x up there in green, okay? So if there's no term with x, do the purple technique where you get the x squared by itself. That's the best way to solve those equations. For all of the other equations, the ones with x in them, we need a new technique, and it's right here. So number 6. We now change gears and solve a much broader class of quadratic equations. Quadratic just means the highest power is 2. A quadratic equation written in the form ax squared plus bx plus c equals 0, where a, b, and c are constants, is said to be in standard form. So we're going to have lots of equations that we solve like this. For example, 3x squared minus 2x minus 4 equals 0. That is a standard form quadratic equation. The a is the number 3, b is negative 2. You got to make sure you grab the sign. And how much is c? not just 4, but negative 4, okay? A, B, and C. All right, so we're going to learn how to solve these kinds of equations today and in the next class. So let's take a look at number 7. 3x minus 1 times 2x plus 7 equals 0. You could distribute here, you know, FOIL or lobster claw or however you think of it. And if you distribute in combined terms, you're going to get something that looks an awful lot like what I wrote over there in blue, right? You're going to get some equation like that. It's legal. It's not a good idea. Turns out this is in a great form for us right now. Fundamentally, this is a product, yes? I'm going to like temporarily cross off. There's some stuff in there, and there's some stuff in there, but whatever those things are, they're getting multiplied together, right? And suppose that you just have two numbers, forget the x's, but just two numbers, and they're getting multiplied together. And I'm telling you the answer is 0. What can you tell me about one of my numbers? One of them has to be 0, right? The only way to multiply one number by another number and get 0 is if one of those two things had been 0. Yes? Like, I don't know what 17 times 24 is, but it for sure is not 0, right? There's no chance it's 0. And 0 times anything gives us a 0. So here's what we do. We say, all right, either this thing right here by itself is 0, and you write that as a separate equation, or this thing in here by itself is 0, and you write that as an equation, okay? You write these two simpler equations, both of them equal to 0. Notice we don't need the parentheses anymore, okay? And those two highlighted equations down there, I could have given you those on the first day of this class. They're easy to solve. Those are linear equations. So for the yellow, we add 1 to both sides and then divide by 3, so 1/3. And in green, what do we do first? Subtract 7 and then divide by 2, so we get negative 7/2. And those are our answers. How many answers did we get? 2. Does that make sense? If we had distributed up here, we would have gotten 6x squared in the beginning. That x squared tells you, yeah, 2 solutions. There they are. Okay, so we're convinced now that if we can somehow get our equation into this form up here, where it's factored equal to 0, then it's easy. So on the next page, we start with this equation. X squared minus 24 equals 5x. It is not currently in that great form that we had before. Don't try to factor just yet. First thing to do is put it in standard form, which means 0 on one side of the equation. So we're going to move this 5x over to the left by subtracting, and we've written that down below. Notice, where did we put that minus 5x? In the middle, which is what our standard order is for these kinds of equations. X squared term followed by the x term followed by the constant term. Okay, so these two equations are equivalent. And now we're going to factor. And so there's 3 kinds of factoring methods that we've learned so far. That's all of them that we're going to learn. First step is to try to factor out the greatest common factor. For x squared and 5x and 24, is there anything that goes into all of them? No, but it's worth checking first. Next step is to try the difference of 2 squares formula. It's 3 terms. It's for sure not the difference of 2 squares. And then the last thing is the 2x2 box, and that's what you do. We're not going to do it here. You will have plenty of practice doing it in the activities, but just trust me when I say I did the 2x2 box and I got this x minus 8 times x plus 3, okay? So there's like a 2-minute process that I've omitted here. But once it's in that form, x minus 8 times x plus 3 equal to 0, now we're in this position where we got 2 numbers and one of them has to be 0 because their product was 0. And so we write separately either x minus 8 is 0 or x plus 3 is 0, and then we solve those 2 equations. Add 8, subtract 3, and we've got our 2 answers. X equals 8 and x equals negative 3. So last thing I'll say here is that some folks, after doing a couple of these, start to grab a shortcut and they say, okay, whatever number is right here. So take a look at that number compared to the final answer. And then take a look at this number here compared to the final answer. Is there a shortcut? What's the shortcut? Opposite sign. Same number, but opposite sign, right? In the parentheses, in blue was a negative 8, and then the final answer was positive 8. Okay, and in green it was a positive 3, and the final answer was negative 3. That is a shortcut, which saves, I don't know, 5 seconds. We're not talking like 3 minutes of your life here. And it's a shortcut that doesn't work all the time, which makes it worthless as far as I'm concerned. Come back down here to the one that we did. If I think about that same shortcut, the number I see here is -1. What does the shortcut say the answer is? +1? Is it? No, it's 1/3. Here I see +7. What does the shortcut say? -7. Was that the answer? No. Don't use this shortcut. It's not worth anything. Right? It hardly saves any time, and it doesn't work some of the time. Okay, so let's move on to the next page. The calculator is no calculators on these, and let's see how far we can get in the activity.